everyone, and thank you for joining us today for our Johns Manville Solutions for Acoustical Design webinar. I'm Natalie Carney, and I will be your moderator for today's presentation. Before we dive into introductions, I'd like to go over a few logistics. If you have any questions or concerns throughout the webinar, you may submit them at any point during the presentation via the Q&A or chat feature at the bottom of your screen. We will address these questions live at the end of the presentation. Additionally, we will follow the webinar today with a survey. This is your opportunity to provide us with feedback on how we did today, ask any additional questions you may have about the topic of the webinar, or suggest new topics for webinars you'd like to hear in the future. We are continuously striving to improve and evolve our webinars, so if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like we missed the mark today, we'd encourage you to fill out the survey. We use your feedback to improve our webinars and provide the information that has the most value to you. Also, we are frequently asked whether or not we send out these presentations upon their conclusion. While we do not send out the presentation itself, we do post a recording of it online for you to watch at your leisure or share with your colleagues. This ensures that you can have the presentation within its full context. Now with that, we'll dive into some introductions. Joining me today is Chris Hoying and Danielle Ashley. Chris, could you start us off with an introduction and then we'll follow with Danielle?
Sure. My name is Chris Hoying. I run the Acoustics lab at Johns Manville, which is located in our technical center just outside of Denver, Colorado. My background's in building acoustics and noise control between some consulting as well as some lab and field measurements of acoustic assemblies. I'm a member of INCE and the ASTM E33 committee, which deals with acoustic test standards as well as Acoustical Society of America.
And hello, everyone. My name is Danielle Ashley. I'm a research scientist at JM. I'm also located at the Technical Center in Littleton, Colorado. I've been at JM for 5 years, and I primarily focus on product engineering support for building installation. And prior to coming to this industry, I have previous experience in developing and commercializing specialty products. And I have involvement with, some of the industry organizations such as ASTM, NEMA, and I'm currently one of the consensus committee members of the Commercial Code Committee forming the IECC 2024 edition.
Thanks, Danielle. I'd like to run through a quick overview of what we'll cover throughout today's webinar. We'll start by covering acoustics and noise control basics. Then we'll get into sound control and sound transmission, followed by sound absorption, and finally run through how JM can provide solutions for both your residential and commercial needs. All right, so with that, I'll pass this over to Chris.
Great. Thanks, Natalie. All right, so let's first dive into why we want to control sound. We're mostly driven by occupant comfort. If you're looking to create a usable, habitable space, that may be something that you're living in, like your bedrooms and living areas, or schools where you're ensuring that students are able to hear instructors and stay focused, or hospitals where patients need quiet rooms and speech privacy can be of a concern, or where acoustic or amplified performances can happen. You have a space that you want to ensure that there's a quality experience and also getting repeat customers. And these are all they drive the creation of codes and specifications. So those codes and specs will control how almost like a quantification of those parameters that we typically have fewer issues. Design teams and contractors may be often looking at this side of the ball, but their intent is to create usable and comfortable spaces. Additionally, you might be seeing individuals opting to work from home, though it may not be really captured well within our codes yet. This may be a consideration in new construction or possible renovation in current existing residential spaces. So let's talk a little bit about what sound is. So Basically, it's a very, very small pressure disturbance. Atmosphere is described, well, it's at sea level around 100,000 pascals, while sound is being measured on the scale of micropascals. It travels as a pressure wave in all directions, and can be similar to like a droplet falling into a pool of water, but instead of the wave is traveling in 3 dimensions rather than just 2. Sound is quantified in definitions of loudness or volume and frequency, which can also be described as pitch. And these patterns of waves over time will be a means of describing the quality of it. So here are some of those parameters that we do have to describe sound. So loudness of a sound is determined by the height of the sound wave, where you look at the difference between maximum pressure versus a steady state pressure, which would be atmosphere. And we could also derive frequency by looking at the width of a sound wave. And this is looking at the time that transpires between peaks and troughs, sorry. And the number of periods that happen over a second will be described as a frequency, which has units of hertz. And the final bullet here is on A weighting. So you may have seen on data sheets with equipment that makes noise, there may be a rating in either decibels or a decibel A weighted number. And this is often on handheld sound level meters, if you've ever used those. They often provide an A weighting, sometimes even an unweighted overall level. So A weighting is a filter that models what our human ears interpret. As you can see, at lower frequencies, these levels are a bit reduced, and mid to higher frequencies, they're not. And you can notice this when you hear a high-pitched alarm or a young child screaming, as our ears are a little more sensitive in that region versus a similar amplitude emanating from like a subwoofer. And I did mention decibels. So they are the smallest change in level that we as humans can perceive. That being said, a change in 1 to 2 decibels is not really noticeable. And when you get up to around 9 to 10 decibels of change, things sound half as loud or twice as loud. And it's important to note that decibels are a logarithmic scale and not linear. And so here's some examples of how loud things are. A whisper at 6 feet, maybe around 30 decibels, and your volume vacuum or leaf blower will be closer to around 90 to 95 decibels. And getting up to 120 decibels is around the threshold of pain. So let's get into a few of the acronyms that are used to describe materials or assemblies. Acoustics has an alphabet soup of acronyms, and some of these you may already be familiar with, including the ones on the slide, but there's definitely a lot more than what's listed here. The top 2 here, sound transmission class and indoor transmission class, STC and OITC, are single number ratings of airborne transmission loss performance of an assembly. OITC ratings are more common with exterior assemblies since they're dealing with a lot more lower frequency noise generators like traffic and other potential noise sources that may be outside. So you often see it with windows and patio doors. What's important to note here is that OITC does capture a couple more lower frequency bands. So if you're looking at 2 window assemblies that you're choosing between, they have the same STC rating, but different OITC ratings. The one with the higher OITC rating will be an overall better performing window. Next, we have impact insulation class, which is more of a measure of structure-borne transmission loss performance, but we don't delve too much into it in this presentation. But these top 3 are all related to decibels, which we discussed in the last slide. And the final bullet here is on sound absorption. So we have the noise reduction coefficient, NRC, which is a measure of absorption across the most common speech range, which is our 250 to 2000 hertz range. And that's on a scale of 0 to 1, with 0 being totally reflected and 1 being totally absorbed. Now let's get into a bit about the principles of sound control, since we got through some of the basics. So acousticians interpret noise in a sound path source path receiver model. So sound is generated at a source, travels through some medium, and reaches a receiver. The best option to deal with noise is to fix it at the source. So if you have a noisy fan or generator, maybe it needs new bearings, or it could be replaced with a quieter unit, or even relocating it is another option to get it away further from the receiver. All these would be your best options in trying to deal with the noise. But if you can't fix a source, maybe we're talking about the neighbors in your condo building, we can't do too much with those kinds of sources. And most of our presentation will be talking about this. But we can try to reduce the noise along the transmission paths by either improving the wall or floor ceiling assemblies. And then finally, the last and worst option is quieting noise at the receiver. So this would look like in putting your receiver within an enclosure or providing hearing protection. If you've ever been in a noisy factory, you probably saw signs for hearing or double hearing protection. This means that all other attempts to deal with noise issues have essentially failed to quiet the noise, and they have to resort to providing hearing protection. So let's talk a little bit about what those sound sources may be, specifically in your commercial and residential applications. So walls and exterior facades, including roofs, separate spaces from airborne noise sources. That could be neighbors or mechanical equipment, rain and hail on roofs. And then you have floor ceiling assemblies, which separate spaces from airborne noises as well, but they also deal with impacts like footfalls or when your neighbor drops their marble collection or bowling balls. And other sound sources would include HVAC ducts, which carry mechanical noise from whatever they may have upstream or downstream. And equipment vibration can also travel through structure from adjacent spaces or even further away. So we have a few specifications listed here, but there's also a few others that aren't included. But let's touch quickly upon these. So we first have building codes. So International Builders Code, which is usually referenced here in the United States. Canada has National Builders Code of Canada. And IBC requires partitions, that's including walls and floor ceiling assemblies, must either be lab rated at STC 50 and IIC 50 for floors between all dwelling units. And if it's measured in the field, you have a potential of a reduction in this requirement. They recently changed it in 2021 to NNIC instead of ASTC, but they are generally the same. And then next we have schools. For the last 20 years, ANSI classroom acoustic standards has been around. And it's providing guidance to create effective learning spaces. The goal is to maximize the speech intelligibility for teachers and students. And to achieve this with very few echoes, that means we need a lot of absorption. So that's why you have a really low reverberation time listed there. And then also having a quiet HVAC system. And there's not necessarily a requirement. This is a standard, so it may be referenced by the schools to meet those, adhere to that. But then also, I believe IBC section 1207 now has a reference to numbers that are very similar to this ANSI standard. And then finally, we have healthcare, which is driven by the Facilities Guidelines Institute and HIPAA. So this is mostly to make sure speech privacy is taken care of. And then also you have concerns with like NICU patients, your babies, where you want to make sure you have a nice quiet space for them to remain undisturbed. And you'll also notice like there is an absorption requirement. So echoes do help with speech privacy to a degree, but then you also have the concern of trying to have spaces that you can easily wipe down and clean since it is a hospital. So let's go ahead and dive into sound transmission. So I want to point out that STC ratings are only valid for an assembly, not an individual product. STC ratings aren't like our values. They can't be added together. Sound passing through a wall is a much more dynamic process in comparison to heat. So just want to keep in mind that no piece of insulation has a certain STC value. Even if you measure it and get it tested just individually by itself, that value has no meaning once you stick it into a wall. That number only applies if that's the only thing separating two spaces. And the STC ratings that we see in reports, that itself is calculated between 125 and 4,000 hertz. And that's our speech in typical music range. It's mostly to show that performance in that range. It's not a good predictor for road noise and machinery. So that's why we have OITC ratings. Okay, so there's a number of assemblies that we're going to be walking through this in the next few slides. Just want to point out, this is all in our sound management reference guide. It's available online. We have a QR code later, and you can review that in more detail later. We're looking at exterior residential walls. So this first line is a comparison of closed cell spray foam versus open cell. I just want to point out that open cell performs fairly on par to fiberglass when it's stuck into a wall cavity. Closed cell spray foam really doesn't perform as well. And then on this bottom line, so we have AP foil, I think it's R5, and then a layer of sheathing and a few different options for exterior assemblies. So the first one's vinyl lap siding, second one's fiber cement, and then the last one is stucco. Stucco performs the best of the three, given the additional mass that it adds to the assembly, and then fiber cement's in the middle, and vinyl is lower. So I do want to point out polyiso, any kind of like AP foil product, those products really don't perform acoustically just because they don't add a lot of mass to a system. They do add some vibration isolation component, but not a lot. So now let's look a little bit at interior assemblies. I just want to point out in this presentation, we're just looking at data on wood wall studs. Our reference guide has a lot more on steel studs. You may note that our data is mostly with 25 gauge studs. When there's no resilient channel, those numbers are higher than these, and that's due to the thin section of 25 gauge steel is pretty flexible, and it provides a vibration break compared to a solid wood stud. So when you go to a heavier stud, similar to like 16 gauge, 20 gauge, or even if you're going to 12 or lower, those will result in similar performance to wood studs since they approach the same stiffness as wood studs. So this slide is showing that as we add insulation going from the left column to the middle column, our STC rating is increasing. This is pretty significant in the bottom one, which is a double stud wall. And it's almost a 10-point jump. It is a 10-point jump. The first row is showing single studs, and the middle assembly is with, well, the first two on the left are with 1/2-inch jip, and the top right one is with 5/8 jip. So we're not seeing a large jump in performance when we're adding this insulation. And this is mostly due to the amount of noise that's able to pass through the studs. So to get to a higher rating, you consider going to like a staggered stud assembly, and that's our middle row. You can note that we are getting a substantial jump in performance once we add insulation to those cavities. And then middle to comparing to the right one, we have an additional layer of jip being added. Just want to point out, it's only adding a couple of points. You can get an increase when you're adding jip to an assembly, but you do have diminishing returns once you get past a certain point. And then finally, the bottom row, if you got the space, it's ideal to go to a double stud assembly. And you're seeing a lot better performance with this assembly because you don't have a shared top and bottom plate as you do with the staggered stud. You actually have a physical airspace between those two stud rows. So that's why we're getting a lot better performance. And that's helping us out quite a bit with that rating. So I just want to point out, you may be trying to shoot for code minimum IBC. STC 50 performance. These 4 would be your best bet to get close to that. And they may work well where you have space available. So that would be good for like your multifamily demising systems, or even single family walls where you're looking for higher performance, maybe with like a home theater room. But there may be instances where space is a premium. So that's when you want to consider maybe using a vibration isolation product. So I'm just highlighting 2 here, resilient channel and isolation clips. They can be installed on the stud, and then you attach your gypsum board to that. Just want to say that this is providing a good vibration break, similar to what a double stud assembly does. And assuming it's properly installed, especially with resilient channel, they can be a good means of getting to STC plus 50 performance. But what about you have your exterior walls where you're looking for better performance? You may be close to a highway or an airport or some other noise source. It may be best to increase the mass of the exterior facade, or adding fibrous insulation to the cavities instead of just relying on the polyiso products, or even going to like a 2x6, or even using an isolation product on your interior wall. And also it'd be best to be using STC 35 windows plus, since those will be your acoustic weakness if those are included in your assembly. So this is just a recap of what we kind of just covered in these slides. Again, just please note that these are not simple linear additions. We can't combine resilient channel with double studs to perform to get a high performance wall. Every wall's a little bit different. It's not like R value. So let's talk a little bit about sound absorption. So you may have instances where you're trying to reduce reflections, your reverberation in a space. May that be in your classrooms or in the office, or even at your office at home. This is where you would want to add material inside the room, inside the wall, well, inside the space, outside of the walls. So there may be instances in lobbies and auditoriums where you're also looking to add these products. And they, as you can see in this image, they can also be within the space. So like hanging baffles, things of that nature. So I did want to touch upon, again, how NRC and how sound is being absorbed. We're looking at how much noise is being reverberated off of material. So that's that 0 to 1 range. And so we have a different smattering of products listed here. We have bricks, we have gypsum board, and fiberglass. And you can note that with like brick and wood floors, like there's a lot of reflection. So it can create a very reverberant space, which is very typical in today's construction. But if you're adding carpet to a room or something like that, that would definitely help with reducing the amount of buildup. And then also I want to point out, between the 1-inch and 2-inch products of fiberglass, that you see with a 2-inch product that it's performing quite a bit better at lower frequencies. And that's just because it's a thicker product and it's able to deal with the wavelengths of those lower frequencies. So we got 2 figures here. The one on the left is showing a comparison of different thicknesses of mineral wool. And we're looking at a range of 1.5 inch to 6 inch. And then we got a couple of other products there just for comparison's sake. And you'll notice at higher frequencies, all those mineral wool products are performing pretty much on par with each other. But once you get to those lower frequencies, that you're seeing the 6-inch products performing a whole lot better in comparison to the 1-inch and 2-inch products. So your acousticians may be looking at trying to deal with reverberations at a certain frequency band, so they may be selecting products accordingly. And those lower frequencies are really hard to control if you're not able to stick thick products on the walls. And then on the right, we have a comparison of different densities of products. And just want to point out, in comparison to the two, our bigger knob of adjusting performance of absorption is all about thickness. Density really doesn't have a huge impact when we're looking at different mineral wools or fiberglass products. We're mostly getting much better performance with thicker products. And I'm going to hand it off to Danielle here.
Thank you, Chris. So from here, we're going to look more into the role insulation plays on improving noise control. And one thing to keep in mind is that insulation acts as a sound absorber and also helps reduce sound transmission. And there are a few general properties that good sound absorbers have. And so what you're looking at is to have, a material that gives you performance in terms of thickness. So increasing the thickness of a sound absorber will generally improve your performance. Density also plays a role. As you increase density, you'll generally get improved sound absorption, but to a point, at some point you do get to an area of diminishing returns. And fiber diameter and cell size also comes into play. And so generally, as you decrease fiber diameter or cell size, you will get some improvement in sound absorption. And overall, if you're just looking at, what type of material would make a good sound absorber, the material really should be porous. And that does go back to the point that Chris made earlier, where you're not going to get as good of sound absorption performance from something like a closed cell spray foam or a polyiso product. Now, as we look at different types of insulation and we try to describe or assess their role in acoustics, there are a few ways to look at the performance, and we're looking at performance in terms of quantifying sound absorption and sound transmission. So when we're looking at noise reduction and we're trying to assess the performance of insulation, it's really critical. I'm kind of re-emphasizing a point that Chris made. But when we're talking about insulation as a standalone product, and we're just measuring the insulation's performance from the standpoint of sound absorption, we'll use an ASTM C423 test. And so that's a test method where we're essentially quantifying the amount of sound that's absorbed by a single material in a reverberation room. Whereas if we want to try to quantify the performance of, as described by sound transmission, that is an assembly performance test, and there's a test method called ASTM E90. And that method, what you are essentially are doing is creating an assembly, and from the standpoint of insulation, we're putting insulation into that assembly, and so we're looking at the performance of that assembly as a whole, but by understanding which type of insulation product we've put in there, we can see how the insulation contributes to the whole system performance. And in today's webinar, we're going to have a portfolio spotlight on a couple of Johns Manville's insulation solutions. So we'll be focusing on fiberglass and mineral wool insulation. For anyone that's not familiar with these insulation products, fiberglass is generally just comprised of long, resilient glass fibers that are bonded with a resin. And typically, fiberglass products will be characterized by being lighter density materials, whereas mineral wool insulation is made of fibers that are formed from basalt, which is a volcanic rock. And mineral wool products are typically higher density compared to fiberglass. So Chris previously introduced us to measuring acoustical performance in terms of sound absorption. And again, recall that this is a property that's measured for a single component. So what I have on the chart here is results from the ASTM C423 test method. And this chart shows performance results for JM's fiberglass product. And what you're looking at is the the results across a range of frequencies, and just keep in mind that higher values represent increased sound absorption. So what I'm going to ask everyone to do is walk with me through a thought experiment. So we're looking at the performance of fiberglass insulation. I'll ask everyone to picture, how do you think mineral wool performance would turn out if you compare this to fiberglass? So kind of, make a visual in your mind and keep that in mind, and then I will show you how mineral wool compares to fiberglass. And I asked you a trick question. So when we overlay mineral wool data in the same ASTM C423 test method, the mineral wool data is shown with the green plus signs, as compared to the fiberglass, which are the blue circles. And you can see that across the range of frequencies that were used in this test, the fiberglass and the mineral wool results, there's really no differences. The differences are minimal and not detectable to the human ear. And so in summary, from the standpoint of sound absorption, both of these products are good candidates for performance. Now, let's focus on the acoustical performance as related to sound transmission through an assembly. And so this is an assembly test. We're really just trying to look at comparative differences when different insulation types are included as a part of the whole. And so what we're looking at on this slide is the performance of JM fiberglass insulation that's placed in a 2x4 wall assembly using wood framing that's placed 16-inch on center. And the results, again, are looking at the fiberglass performance across a range of frequencies, and the higher values represent decreased sound transmission. So again, I'll ask everyone to do another thought experiment. We're looking at the fiberglass results. Picture what you think mineral wool results might look like. And sorry, that was another trick question, because when we overlay mineral wool results, again, the green plus signs are mineral wool on this chart, blue circles are fiberglass. What we see is that the mineral wool and the fiberglass results are, essentially equivalent in this assembly evaluation, and that just, indicates that as a cavity insulation, both of these are going to give you good performance. These are both essentially coming out with an STC rating of 47. So when it ultimately comes down to insulation selection, both the fiberglass and the mineral wool insulations will provide similar acoustic performance in an assembly. And so the real question for selection is which product is going to meet the specific needs of an application. Both fiberglass and mineral wool products meet the requirements of non-combustibility as measured per ASTM E136. One thing to note, though, is that the melting point of fiberglass is in excess of 1,000 degrees Fahrenheit, while the melting point of mineral wool is shifted higher to in excess of 2,000 degrees Fahrenheit. So some of the key differences between these two product portfolios are really more in terms of their available options. JM's fiberglass insulation portfolio comes in, has options for both unfaced and products that are faced with a variety of vapor retarders. So we have vapor retarder options such as craft faced or FSK 25 or Comfort Therm, which is an encapsulated product. And these vapor retarders represent a range of vapor permeants, and we have materials which also meet the 2550 flame and smoke spread ratings, as measured per ASTM E84. Whereas with the mineral wool product portfolio, there are unique options like Cladstone, water, and fire block, which are designed to be moisture repellent and are suited for exterior continuous insulation solutions. So that's really, the highlight that we have for the fiberglass versus mineral wool performance. And I'm going to hand the presentation back over to Chris for a few closing points.
Great, thanks, Danielle. Just want to cover a few questions and misconceptions that commonly come up. So we're first going to look at transmission loss. Do I need to fill the cavity with insulation? Do I get more performance if I overstuff a cavity? And Jerry asked a question, so I may include that as well. He was asking if we double the insulation into double stud wall assembly, what happens to the performance? Somewhere in the realm of 1 to 4 points will be added to the STC rating. Generally, it's best to fill the whole cavity if you can. It's not worth overstuffing it. You're not getting additional performance, but at a minimum, it's recommended to fill half of the cavity with some kind of porous insulation, and you just have diminishing returns as the rest of the cavity fills. Again, polyiso and closed cell foams really don't perform acoustically, so they're not adding a lot of value outside of where spray foams may be able to seal up any kind of gaps. So if you're doing a hybrid system, those perform quite well. Is transmission loss affected by stud spacing? So this is taken from a study that was completed by the National Research Council of Canada. And we're looking at a system that has gypsum boards, and we have 2x4s installed, and we're just looking at the spacing that they attached their studs down to the top and bottom plates. On the right, you see a breakdown of what these ratings look like. So they started with 12 inches on center and went up to 32 inches on center. And yes, they are affected. It's a lot more apparent with wood as well as with 25 gauge studs. Depending on the test reports you look at, that's also applying to 16 gauge and 25 gauge studs as well. So the further out you go, often you'll see test reports done on 24-inch on center just because they get good performance numbers in comparison to 16-inch on center. So those don't always carry over. If you see a report on 24-inch on center, that should not apply to a 16-inch on center assembly. Are all studs the same? So this was a study done by Veniclaus and Associates. So we're looking at a few curves. On the right is basically the breakdown of the STC ratings. 16 and 20 gauge studs are performing pretty much the same. This is with 2 total layers, so 1 layer on each side of the wall, and a 25 gauge stud is outperforming them by 5 points. And let's look at a couple of things that you may see with sound absorption. So this is also related to transmission loss, the comparison of NRC ratings versus STC ratings. If you have an NRC rating for a product, some kind of insulation that you'll be sticking into a wall cavity, it does not have a direct correlation to STC performance and vice versa. So NRC ratings are moot once you stick something into a wall cavity and cover it with gypsum board. So on the right, we see this figure where we have an unfaced fiberglass product being exposed, and we did a C423 test on that. And that was just laid on the floor, nothing on top of that. So we get really good absorption with that product. But once we stick that behind a wall and we have a gypsum board covering that material, you have the same performance that you would see with just a gypsum board or on par. So you're getting a lot more reflectivity as a result of covering it with gypsum board. And then finally, you may have seen in that table that we had sound absorption coefficients, some of those numbers were above 1. Is that realistic? So when C423 tests are done, they're typically laid on the floor with the edges exposed. So we do have a standard to cover those up just to reduce the amount that they will absorb on those edges, but you still have diffraction and edge effects happening where that material is thicker. So you're seeing where those numbers may be increasing just because it's not only insulation or the product being tested by itself. Additionally, you have sound waves attacking it from random incidences. So the material can appear thicker than what it would be looking at it perpendicularly. So waves will interact with it differently as you get to these random incidences. And I'll leave it to Natalie to wrap this up for us.
All right, thanks, Chris and Danielle. Before we dive into questions, I'd like to take a few minutes to go through some additional resources we have for you guys. First and foremost, we maintain all of our informational resources on an online portal called The Source. This is where you'll have free access to our recorded webinars, blog, product documents, and specifications, trainings, and tools. We strongly encourage you guys to browse this section if you're looking for detailed information about our products or leading industry news. If you'd like to take a second to scan these QR codes, as you can see, this first one will take you to our JM Building Insulation product portfolio, and the second will take you to our JM Sound Management Guide. The Sound Management Guide will give you the option to download and save it. It's an easy-to-use guide to determine the most appropriate assemblies to meet your STC requirements. Also, follow us on social. Our Building Insulation LinkedIn page features the latest news and insights. Our YouTube channel hosts many informative videos, and our Insulation Intel Twitter account provides an industry-wide look at current trends and news. Finally, I'd like to highlight JM Tech Connect. The Tech Connect team is available to all JM customers. Whether you need help with installation, troubleshooting, parts and equipment, or even specifying questions, our experts are here to help. For anyone who attended today, you will receive a certificate of completion after the webinar that may be submitted for professional development hours. This will be sent to you via email and should be in your inbox by next week. Again, a recording of today's webinar will be posted on The Source within the next couple of days. When it's live, we'll send you a link for direct access. So if you missed any part of the presentation, you would like to view the webinar a second time, or feel the content might be relevant to a colleague, you'll be able to access it on demand. And with that, let's dive into some questions. Danielle, this first one looks like it's for you. In your opinion, which product is superior for interior acoustics between rooms, fiberglass or mineral wool?
In my opinion, so I have to admit to being a little bit biased towards fiberglass because that's the product that I work on. But honestly, in an assembly, both fiberglass and mineral wool are going to give you good acoustical performance. So I would base the decision on what would work best for that design, you know, as far as other potential properties that are needed for this specific application.
Okay, thanks, Danielle. Second, we have, what happens to the STC in a cavity if you double the insulation in a double-sided wall assembly? Chris, I think this one might be for you.
Yeah, hopefully I did address that when I went through the common misconceptions. Hopefully that addressed it. Please let me know if you have any further questions about that, Jerry.
Okay, thanks, Chris. The phased fiberglass batt products have different acoustic performance. Danielle?
In an assembly, the different fiberglass products are going to provide an overall equivalent performance as far as sound transmission. There will be some slight differences on material sound absorption, but if you're just looking at, you know, in an assembly, you won't see any appreciable difference with sound transmission based on the specific phased or unphased fiberglass product.
Thanks, Danielle. Chris, would using mineral wool in a ceiling help reduce footfall noise from the floor above at all in your basic wood frame home? What cost-effective products does JM have that could help combat footfall noise without starting from scratch?
Great question. Well, that's a loaded one. Just because if you're dealing with airborne noise, yes, adding an insulation product to that cavity is very ideal. But if you're dealing with footfalls, impact issues, insulation alone is probably not going to cut it. And that really depends what your finished floor is. If it's carpet, carpet usually does really well with footfalls. But if you're using LVT or something like that, you will likely need to consider either an underlayment for your finished floor or an underlayment for your gypcrete, if there is gypcrete, or you can look at options where you're replacing the ceiling attachment, either going to a resilient channel, ensuring that it's properly installed, or going to an isolation clip or something similar.
Okay. Chris, again, is NRC or STC more important for interior commercial applications?
So if you're talking about reverberation time, NRC values is where it's going to matter. But if you're concerned about performance between two adjacent spaces, then you're going to be looking at STC performance. There may be some instances where you want to reduce the amount of buildup within a room. So adding absorption in that space can help result in how much noise is actually breaking through that assembly. But that's the only time there's any kind of correlation between the two. But NRC for reverberation, STC for transmission loss.
Okay. How much difference is expected between bats and blown-in fiberglass in a wall?
I'll rely on Chris to keep me honest, but I really don't believe that there should be an appreciable difference between bats and fiberglass in a wall. I'm more familiar with bat data, but because those are both products that have all of the properties of a good acoustical performing material, I really don't see why there'd be any appreciable difference.
Correct. I would say there's maybe a difference between cellulose and fibrous products, but between blown-in wool and fiberglass, mineral wool, those all perform pretty much on par.
Okay, we have, is there a variance in sound quality for fiberglass and or mineral wool installations over a 30-year period?
Good question.
Again,
Yeah, go ahead,
I'll let
Dave.
Chris answer that one. Oh, no, you go
geez.
ahead.
I mean, I've tested stuff in the field that's been over 50 years old and it still performs pretty well acoustically, but products do break down. I can't speak to that regard. As long as it's still filling the cavity and holding up well, hopefully that's not an issue. I don't know if you have anything to add to that, Danielle.
Yeah, I was pretty much going to echo that because both fiberglass bats and mineral wool products are formed products that are designed to fill cavities, and they're stable products. And so since you don't have any settling or any deformation over time, then I don't expect that there would be any difference in acoustical performance. Again, you know, you might have a difference over time with something that settles, like a cellulose type product, but you don't have that type of effect for fiberglass or mineral wool.
Okay, next we have, in your experience, how often do classrooms meet 0.6 absorption?
I can take that on. If there is carpet and an acoustical ceiling tile, either like an NRC rating of 0.6, even like 0.5 or above, they will typically meet 0.6 second reverberation time, especially if the ceiling's like within 10 or 11 feet tall. Once you get into like science classrooms where there's hard floors, that can be a little bit harder to achieve. So you may have to look at like a higher rated NRC ceiling tile or even acoustical wall panels if that's achievable. But if the ceiling does get higher, you have a larger volume, that can definitely add to the reverberation time. But in most classrooms, carpet and ACT are in good shape.
Okay, next we have, is there any carcinogenic risk with mineral wool today as in earlier decades?
I will try to field that one. I'm assuming that the concern might be with regards to indoor air quality, and you know, there are indoor air quality certifications that JM products meet. Namely, I'm thinking of Green Guard, and I'm trying to double check because I'm less familiar with mineral wool, but I do believe mineral wool products do have a Green Guard certification. The mineral wool products are different from fiberglass in that fiberglass, the resin is formaldehyde free. But I think when you look towards industry certifications, that the JM mineral wool products are demonstrated to be, on par with the market as far as, meeting indoor air quality needs.
All right, thank you guys. There's also a question, acoustic performance and comparison of double stud versus staggered studs. Could you please provide further explanation as the staggered studs do not touch and should have less transmission versus double studs in typical wood stud wall?
Yeah, I'll take that. So the issue with stagger studs is that they share a top and bottom plate. So vibrations can carry through the plate itself or through the studs to the plate and back through the other studs. So that's why you're seeing a reduction in performance in comparison to double studs, where you actually have a separation of those top and bottom plates. So that's why that's showing up. And I believe our tests were done with an airspace. It may not be shown very well in those graphics within our reference guide, but we usually shoot for a minimum of a 1/2 inch airspace, or the more the better, really.
Okay, thanks, Chris. Next, we have, would temperature fluctuation play a part with STC rating assemblies?
Good question. Hopefully, if you're talking within the realm of what us humans can survive, I'm not aware of any difference in performance acoustically of assemblies as that changes. So they should remain the same. We do have some correction factors for humidity, as sound will act differently if you're in a really dry environment. As you have high frequencies, they just don't travel as well in low humidity in comparison to high humidity, where high frequencies travel a lot better. So humidity is a bigger factor, but it's mostly about in the space itself rather than transmission loss when you're looking at going through an assembly.
Thanks, Chris. We have a few more coming in. Are there any product options to enhance acoustic properties of large glazing systems on facades close to highways?
Yeah, I'll take that one as well. You got to pick a good glazing system that has a high STC rating or OITC rating. There are opportunities to pursue better sound absorption. I believe there are acoustic glazing systems that can absorb sound a little bit better than just a glazing panel, as you typically see. And then if you're concerned about noise between two adjacencies within a building that has a glazing system, you just need to make sure you have a really good mullion product that's acoustically rated to achieve a certain STC rating, because you'll have a lot of noise breaking through if that's not really well sealed to your glazing system.
Thanks, Chris. Next, we have, regarding sound transmission prevention in wood frame stud cavities, is there any advantage to placing the bat insulation perpendicular to the wallboard? What sheet, membrane, and/or adhesive products are advised to use over the studs and behind the wallboard?
I can take that one as well. So if I understand what they're asking correctly, they're looking at to rotate the insulation product in another manner. As long as the product's there acoustically, it should perform the same. I can't say the same will happen with thermal, just because those products are designed to be installed in a certain way. However, I do want to point out, I don't think you want to be sticking anything in between your studs in the gypsum board in terms of insulation products. If you're thinking about doing an isolation product like resilient channel or isolation clips, those would definitely help increase performance. But then there's also like products like green glue and things like that, where you adhere it or put it on the surface of the gypsum board before you add another layer. I'm not crazy about those products just because they're really expensive. You have to use like a bottle of caulk for each individual sheet of drywall, and it's just a lot harder to deal with that in comparison to RC. That's my own personal bias, but to each their own.
Thanks, Chris. Next we have, are these products fire rated?
Yes, both the fiberglass and the mineral wool products they're fire rated in terms of non-combustibility. Both of those products meet the requirements of non-combustibility per ASTM E136, and both of those products also meet the requirements of less than 25 and less than 50 flame and smoke spread ratings per ASTM E84, with the caveat that craft-faced insulation does not meet that. Craft-faced insulation is not fire rated, but the other products are, and you'll find details of the fire ratings on JM's technical data resources.
Chris, next, with the purposes of interior wall insulation being more acoustical, when will architects get rid of the R8 spec, considering most people don't even make that product anymore?
Good question. To my knowledge, Johns Manville doesn't make or is going away from R8 themselves. I'd rather see a thicker product being used in those instances anyway. So that's up to the architects, and hopefully just updating some of their drawings so that they're no longer using the R8 product.
Yeah, just to add to that, JM previously had a product that was called Sound Shield, and to Chris, to your point, we don't offer that any longer, but we do recommend the use of the R11 BAT product, which is going to be even better for a insulation solution than Sound Shield.
Okay, Danielle, can fiberglass or mineral wool insulation be used on top of drywall to retrofit an existing room?
Both of those products are really intended and designed to be used as cavity insulation. As far as trying to retrofit an existing room, I think that is a specific type of application that would lend itself well to a more, I guess, detailed acoustic design, kind of similar to the points that Chris mentioned earlier in the presentation. And likely, you know, a good acoustical retrofit solution would involve potentially at least retrofitting the cavity or doing something else with the assembly. It's really not a good solution to assume that you could put a cavity insulation on top of existing drywall.
And I may add to that, when you have an assembly with two cavities, it usually does not perform as well as if you had one single cavity.
Okay, thanks, guys. If we did not get to your question today, we will follow up with you within a few days via email. Thank you all very much for attending today. We hope you found this information useful and relevant. If you have any questions, please don't hesitate to reach out to us directly or via the survey that will pop up on your screen directly after the webinar. Otherwise, take care and enjoy the rest of your week.